Hi guys, welcome back. In this video, I'll be explaining inverse of a 2 by 2 matrices. But before I continue, let me remind you about identity element and inverse element. You know, in linear algebra, we have identity element and inverse element. If you don't forget, when we say identity element is an element you are going to operate with a number. Any number you operate with a number that gives you that number back is known as identity element. E is identity. So I don't know if you've not done your binary operation. I'm going to have another video for that in future. So in essence, what are you going to add to A to give you A back? You know it is 0. Then we say 0 is what? Identity element under addition. So identity element under addition. So likewise, what are we going to multiply by A to give us A back? You know that is 1, right? Because 2 times 1 is 2, 4 times 1. So any element you are going to operate by an element that gives you that element back is known as what? Identity element. So now that we understand what identity element means, so what of inverse? When we say inverse element is such an element you are going to operate with a number that will give you identity element back. Let me explain in a layman. So, we know that identity element under addition, we know it is 0. So then inverse element now implies that what are you going to add to an element A that will give you identity element 0? You know that is what? That is minus A. So it means minus A is identity element under what? Under addition for any arbitrary A. In essence, so what am I going to add to 2 to give me 2 back? You know what I'm going to add to 2 to give me 2 back is minus 2, which is 0. I hope you understand. What am I going to add to 2 to give me 0? So which is identity element. So that's minus 2. It means minus 2 is inverse of 2. So we call this additive identity. We also have multiplicative identity. Multiplicative identity. So when we say multiplicative identity, that is what are you going to multiply by an element to give you identity element under multiplication. What am I going to multiply by 2 to give me 1? You know 1 is an identity element under multiplication. That is what? That is half. I hope you understand. In general, I'm going to multiply 1 over A by A to give me 1 back. So if that is cleared, we understand the concept of identity as well as inverse. Again, what you operate by an element that gives you that element back is an identity element, which is E. So likewise, what you operate by an element that gives you identity element back is an inverse. So we can apply this context. We can apply this in the context of matrices as well. You know, in the first video, I told you that we have 0 element. So, and I explained that 0 element is additive identity under matrix. What I mean by additive identity is what are you going to add to an element to give you that element back. So if I have this matrix 1, 2, 3, 4. So then what am I going to add to 1, 2, 3, 4 to give me 1, 2, 3, 4 back? You know it is what? 0, 0, 0, 0. You know, 1 plus 0 will give me 1, 2 plus 0 will give me 2, 3 plus 0 will give me 3, 4 plus 0 will give me 4. So this is known as what? Identity element under what? Under addition, under plus in what? In matrix. Likewise, we also have an identity element under multiplication. I hope you understand now. So in matrix, identity element under multiplication is what? Is your unit matrix. What is unit matrix? That is, it is the same thing as identity matrix. I told you it is also a square matrix. So that is when you have 1, 0, 0, 1. That is for what? So that is for a 2 by 2 matrix. That is a matrix whereby all the elements are 0 except those on the leading diagonal whose elements are unity. I hope you understand now. So likewise for 3 by 3, we have 1 0 0 0 1 0 0 0 1. That is 3 by 3. I hope you understand now. So it means if we use the same idea, so it means if I multiply 1 2 3 4 by 1001. Don't forget I said this 1001 is what? It's an identity element. By the idea I gave here, that is when you operate an element with its identity element, then you are going to have that element back. It means we should be able to have 1, 2, 3, 4 back. So let us see. Okay, let us multiply. You multiply row by columns. That's going to give you 1 times 1, 1 plus 2 times 0, 0. Oh yeah, the same row with this column, and that will give you what? So that is going to give you 1 times 0, 0 plus 2 times 1, 2. I hope you understand now. So then you take this second row, 3 times 1, 3 plus 4 times 0, 0. 3 times 0, 0 plus 4 times 1, 4. So if you see it, you will see I'm going to have 1, 2, 3, 4. I hope you understand now. You know, I operate this identity element I, we call it I 2 by 2 under it's a square matrix 2 by 2 identity element. When I operate it with another matrix, I have that matrix back. It means it is called an identity element or identity matrix. I hope you understand that. So under multiplication. So it means if we now use the same idea, so the same idea and we use it for inverse, it means when you operate, if I have a matrix A now, so it means if I operate a matrix A with its inverse, then I'm going to have I, which is identity element. Maybe this is a 2 by 2 matrix, this is a 2 by 2 matrix, this is a 2 by 2 matrix. I hope you understand now. So that's this idea, that's what we'll be using now. So in essence, if I want to find the inverse of 1, 2, 3, 4, suppose I want to find inverse of matrix 1, 2, 3, 4, then it is not difficult. We know that A dot A inverse will give me what? I, which is identity matrix. So, and my matrix here is what? 1, 2, 3, 4. You understand now? Then you can say let's A inverse. Maybe you make your A inverse to be A, B, C, D. Then I'm going to have what? A, B, C, D as well is equal to I. Don't forget your I is identity element under multiplication, which is 1, 0, 0, 1. I hope you understand now. And don't forget we can have equal matrix like I've explained in the last video. And before you can have that, make this a single matrix by multiplying them together. You know, the relationship between this guy and this guy is multiplication. Then I'm going to have A, that is 1 times A plus 2C. Then you take the same row and multiply with this what column. That's what 1 times B plus 2D. I hope you understand now. So 3 times A, 3A plus 4C, 3B plus 4D is equal to what? 1, 0, 0, 1. And don't forget, if a matrix is equal, if two matrices are equal, then their corresponding elements are also equal. It implies that row 1 column 1 of this matrix will be equal to row 1 column 1 of this matrix. That is, A plus 2C is equal to 1. Row 1 column 2 of this matrix will be equal to row 1 column 2 of this matrix. B plus 2D is equal to 0. Row 2 column 1 of this matrix will also be equal to row 2 column 1 of this matrix. That's 3A plus 4C equals 0. And row 2 column 2 of this matrix will be equal to row 2 column 2 of this matrix. That's 3B plus 4D equals 1. I hope you understand now. So then you can call this equation 1, equation 2, and this can be equation 3, and this can be equation 4. So from here, maybe from equation 1, I can find the value of my A. Since A plus 2C is equal to 1, so it implies that my A will be what? 1 minus what? So 1 minus 2C. I hope you understand now. So it implies that A is equal to 1 minus 2C. Then I can put A is equal to 1 minus 2C in equation 3. You know, if I substitute it here, I will have all my value in terms of A. Then I should be able to get it after that. That's 3a plus 4c is equal to 0. Then I have 3 into what? What is my a? 1 minus 2c plus 4c is equal to 0. If you open the bracket, we have 3 minus 6c plus 4c is equal to 0. That's going to give me what? 3 minus 2c is equal to 0. So then you have 2c is equal to 3. And your c will now be what? So it implies that c is equal to 3 over 2. So since I know that my c is equal to 3 over 2, I can now substitute it. Maybe you call this equation 5. So you now say put c is equal to 3 over 2 in equation 5. So if you do that, then I'm going to have a is equal to, we have a is equal to 1 minus 2c, right? So where I see c now, I put 3 over 2, then I'm going to have 1 minus 2 into 3 over 2, and 2 cancel 2. A will now be 1 minus 3, which is equal to minus 2. Okay, now what of b and d? Let us find the value of b and d as well. I can also say from equation 2, b plus 2d is equal to 0. From equation 2, we have 2 plus 2d is equal to 0, which implies that my b is equal to minus 2d. Maybe you call this equation 6. So you now say put b is equal to minus 2d in which equation? You have another equation here. Maybe you call it what? We call it equation 4. That's 3b plus 4d is equal to 1. 3b, so 3b plus 4d is equal to 1, right? And I know my b is what? 2d. That's 3 into minus 2d plus 4d is equal to 1. So then this is what? Minus 6d plus 4d is equal to 1. And this will give me what? Minus 2d is equal to 1, which implies that d is equal to minus half. So then you can just say put d is equal to minus half. Maybe you call this guy equation 6. Yeah, in equation 6. So in equation 6, to know the value of your b, so then I have my b is equal to minus 2d. So and my d is what? Minus half. 2 will cancel 2, then b is equal to 1. Then now we know that my a is equal to, what is my a? A is equal to minus 2. A is equal to minus 2. B is equal to 1. So, and what is our C? So, my C is what? 3 over 2. 3 over 2. And D is what? Minus half. So, D is minus half. So, it means my A inverse, we know we call it A, B, C, D, will now be equal to what? Minus 2, 1, 3 over 2, minus half. You understand now? So that's it. That's how you can find your inverse of a matrix. Though there is a simpler method you can use. I'm going to show you that as well. And don't forget this law that when you multiply A with identity, so the other is immaterial, or the identity by A, then I'm going to have I. That is the identity element. Okay, let us try it. I mean, when you multiply A by its inverse or inverse by A, then you are going to have identity element. Let's see whether we are going to have it. My A is 1, 2, 3, 4. Okay, let me multiply it by my inverse. What is my inverse? Minus 2, 1, 3 over 2 minus half. Let's see if I'm going to have what? Let's see if I'm going to have I. Okay, let us multiply. 1 times minus 2, that is minus 2 plus 3. 2 times 2 will cancel it will remain 3. Multiply this row by this column again. 1 times 1, 1. Minus 2 will cancel 2, that is 1 again. 3, that's minus 6. So plus 6, 4 times 3 over 2. That will give me 6, right? 3 times 1, 3, right? Minus, 2 will cancel 4. That will remain 2. So if you do it very well, you will see that I'm going to have 1, 0, 0, 1. You understand now? So which is I. You can see that my A multiplied by A inverse is equal to Y. So we were able to prove that when you multiply a matrix by its inverse, then you are going to have an identity matrix, which is everything as an identity element. So if that is cleared, we have a simpler method you can actually use to find this. That is a quicker method. Let me explain that as well. If you don't want to stress yourself, maybe you were given an objective and you don't want to stress yourself at all. Maybe you are asked to find the matrix of A, B, C, D. So because in most of your work you might only be asked to find the inverse of 2 by 2 matrices. I don't think 3 by 3 matrices is in your syllabus, although I'm going to cover it in the next video. So if you want to do that, you don't need to stress yourself. The shortcut or quicker method you can use is what? You interchange the element in the leading diagonal. That is, you interchange A with D. So maybe you call this A, then your A inverse will be what? So you interchange this guy. So then, D will be here, A will be here. I hope you understand that. You now change the signs of the element in this second diagonal. This is the second diagonal. You change their sign. If it is plus before, you change it to minus. I hope you understand that. So this will now be about minus B minus C. I hope you understand now. Then you now take, now it now be 1 over, you now take their determinant. Don't forget determinant will now be what? AD, you multiply the elements along the leading diagonal minus the element along the what? Second diagonal. So BC. I hope you understand. So it means we don't want to stress ourselves, and let me use the same example we used the other time. If my A is equal to 1, 2, 3, 4, and I want to find the inverse, what I'm going to do first is to what? Is to find their determinant. Their determinant will be what? 1 times 4, 4 minus what? 2 times 3, 6. You now have 1 over that of their determinant, 4 minus 6. Then you now interchange this guy. You have what? You have 4 here before you put it here. You have 1 here, and you put negative here. This will now be what? Minus 3 minus 2. I hope you understand now. So then your A inverse will now be what? 1 divided by minus 2, 4 minus 2 minus 3, 1. So then if you multiply through by half, then I'm going to have 4 divided by minus 2, that's give you minus 2, 1, minus 3 over 2, and minus half. I think that's what we obtain here. Yeah, you can see the same thing, minus 2, 1, 3 over 2 minus half. So that's the same thing we obtain here. So sorry, this should be 3 over 2 because minus 3 over 2 divided by minus 3 divided by minus 2 will give you 3 over 2. You can see it is very simple. Okay, can you quickly use that to solve this? When I have 3, 4 minus 2, 5. So don't forget, if your A is this, you want to find the determinant, especially when you have it in what? In your objective, just do what? So you just have take 1 divided by their determinant. So their determinant will give me what? 15. I hope you understand now. Minus 8. Then you now interchange this guy. You have 5 here, you have 3 here. So then you put minus here, minus 4. If you put another minus here, this will remain 8. So then I'm going to have A inverse to be what? 1 divided by 23, 5 minus 4, 8, 3. So that's how you are going to be finding the inverse of 2 by 2 matrices. So if you understand, please don't forget to like, share, and subscribe to my channel. So then I'm going to continue from where I stopped in the previous video. Thank you.